All right. Welcome, everybody. And we're just going to hop right in. And the purpose of this class here is to give you an introduction into what it's like to be a civil engineer, what you can expect in your education, what you can expect in your day-to-day career. There's a lot of exciting things that I really want to share with you during this semester. We're going to have a lot of guest speakers come and address you guys from industry as well as from this department. And they're going to talk about the things that they're passionate about and the things that they do as civil engineers. So I'm just going to open up this question and we're going to see how this works. Hopefully it won't be a disaster. So I'm just going to ask the question right now. So everybody clear your yeses and stuff like that. And I want to throw a very open-ended question out there. What, to you, what is an engineer? Let's see if anybody wants to respond. I see a hand clap. I don't know if that means you want to respond, Jacob, but here we go. All right. Benton, I unmuted you. There you are.
Okay, you can hear me, right?
Yep.
Okay. So an engineer is a person who uses the world around them to improve the world around them.
I like that definition. Uses the world around them to improve the world around them. Nice. Okay. I like that. Let's scroll down here and see if there's anybody else. There's 178 of you apparently in this class. So anybody else want to respond? Okay, I'm getting some comments in here. Someone who designs something, says Jacob Willis. Makes stuff that works, says Emily. It's an applier of physics to design, that says Talmadge. I like that, Talmadge. I've had Talmadge in some of my earlier classes. Nice to see you again, Talmadge. A problem solver. Darren Flake says an engineer is awesome. I can't disagree with that. Caden says engineer fixes stuff. So all of these answers I can't disagree with because I think they are correct. Here is, oh, Madeline just put one in. It says, Madeline says, take something good and make it better. And Trevor says it's a creative thinker who uses the world around them to make life easier. I love all of these answers. So there's actually an association called the American Engineers Council, the AEC, and this is what they have to say. They define an engineer as engineering is the creative application of scientific principles to design or develop structures, machines, apparatus, or manufacturing processes or works utilizing them singly or in combination. So it's basically we're taking science and physics and we're applying it to the real world. And we're doing it for the embetterment of society. That's what an engineer does. So an engineer is an applier. Is that even a word? You don't need to speak good English to be an engineer. Don't quote me on that. But it is an applier of science and physics for the benefit of man. So the whole idea is we're going to take the knowledge that you have of science and of math and of how all the things work in the universe, and we're going to use them to make life better, more convenient. So there's all these different types of engineers, right? There's mechanical engineers, there's electrical engineers, there's chemical engineers. But the question is, what about civil engineers, right? So I thought first, before I get there, that this would be kind of fun. The word engineer actually was originally kind of developed or circa 1325. This is like medieval times. And it came from an engineer, right? Engineer. That's where, and the word engine refers to a, yeah, that's right, a siege engine, right? It's something like where we're going to go. I'm not a siege engine, a siege engine. So like a catapult. And so, you know, that's a schematic of a catapult. Here's a picture of a real catapult I saw. Interestingly, catapults are actually really poor siege engines. There's lots of better siege engines that, believe it or not, civil engineers designed, like the trebuchet. The problem with a catapult is you've got that, you have to have this wooden stop, and they've got this arm flinging with huge energy, and that arm hits against the wooden stop and it breaks. And so catapults were always breaking. But at Jacob Willis says BYU trebuchet. I don't know if we've ever built one here at BYU, but that would be stinking awesome if we did. I know that they have places where they build trebuchets and they launch pumpkins across like soccer fields. I think, yeah, I'm seeing a lot of excitement there in the comments. I think that should be a new tradition we start in our department. And we could do like target, like prizes for accuracy and stuff like that. Yeah, civil engineers invented trebuchets. And the nice thing about it is there's no impact. Everything is really oiled and moves smoothly. So if you ever watch The Lord of the Rings, and when they're the big white city and they're launching these huge stones, those are all trebuchets. Well, yeah, Samuel says ballistas. Yeah, ballistas are good too. I personally prefer trebuchets though. Okay, so that leads me to this question. What is a civil engineer? Does anyone want to take a stab at it? What do you guys think? Anybody? I need to get a mouse for this computer. There we go. Okay, Darren, go. Darren Flake. You there?
Yep. Somebody that makes permanent structure for public use.
Permanent structure for public use.
Like makes permanent structures for the use of the public.
I like that. Okay. Yeah, I'm not going to disagree with that. Okay, Jenna. Jenna Harrison, is that right? Okay, I'm going to unmute you. Okay.
It's a person who works on infrastructure like roads and buildings and pipes and all of that.
Okay, and I'm going to add one more question. What's infrastructure? You use that word.
It's the, I guess, buildings or structures in a community.
Yeah, okay. So it's all the structures that go into our society or into our community. So a couple of people who, Kate Freeman says a civil engineer is one who builds trebuchets for public use. Yeah, not quite, but still funny. Designer of infrastructure, says Jana. Okay, Griffin, an engineer specializing in municipal design and construction, dams, motorways. A civil engineer is an engineer that focus on public works or structures, says Aaron. So these are all really, really good. Trevor gives me a really good answer here. It's someone who applies the principles of science for the betterment of cities and towns. They build and design things to last for many years after they're built. That's right, Trevor. Nice job. So the term civil engineer was originally given to these types of engineers because they built civilian structures, meaning for the public, as opposed to military engineer, which was for the, yeah, you guessed it, the military. So it was one of the earliest forms of professional engineers. Civil engineers have been around since officially since like the 1500s. And so we have a very long and a very proud history. So here's what we're going to do. Here's a picture here. I want everybody to look at this and go ahead and clear all of your raised hands. Everyone put your hands down for a minute. And I want everyone to take a look at this picture. Now, down in the comments, I want you guys to write something in this picture that relates to civil engineering. What do you guys see? Okay, arches, says Philip and Griffin. Okay, yeah, it's right in the center. It's right in the center, the bridge, right? The arches and the bridge, okay? Tunnel, aqueduct, dirt, dirt. Yes. Whoever said dirt, I love it. Okay, buildings, roads. Yeah, look at it all come flying in. Someone even said rock. Is rock part of civil engineering? Yeah, absolutely. Because we don't want the rock to come tumbling down on us. And we want the rock to support the loads that we're building on top of it, or the roads. I love it. Bricks, even the grass. Yeah. So I've seen a couple people in here say the bird, the water, the grass. Is that true? Absolutely. Because part of civil engineering is also watching over and being good stewards of our environment. We need to make sure that the world is a good place for us to live, and it's a clean place for us. And so environmental engineering is a part of civil engineering. So someone said the sky. Yeah, I'll even give you the sky, because we worry about air quality. That's another aspect of civil engineering. Gravity, Griffin, I don't know about that one. I'll have to think. We do use gravity all the time in civil engineering, but civil engineers can't own that one. I think other engineers use it too. The point is, when you look at this picture, everybody, you can see that there's a tremendous amount that goes into civil engineering. In fact, wherever you are, if you just look up and look around, you are surrounded by infrastructure. And all of that is civil engineering. We would not be able to live today without our modern day civil engineers. It's just, it's a fact of life. Civil engineers make life better for societies, for nations, for economies, for individuals. And therefore, it is one of the most satisfying forms of engineering, I would say, and gratifying forms of engineering.
Hey, Professor
So,
Frankie.
yes, sir.
I think someone asked a pretty important question. They asked, what was the difference between a civil engineer and an architect?
That's a great question. Thanks, Jared, for finding that. By the way, Jared's one of my TAs, and his mission, along with Stephanie's, is to hunt down really good questions like that come across. So thanks for bringing that to my attention. There is a fundamental difference between civil engineers and architects. Now, we work very closely together, but architects are more involved in designing how a building looks and how to bring certain functionalities into a structure. They worry themselves with how a structure can bring a certain feeling or a certain emotion, or accomplish a certain function for an individual, a client, or society. A civil engineer is the individual who takes the ideas of the architect and makes them practical, and actually says, okay, here's all the math, here's how we're going to make your idea physically work, and here's how we're going to build it. Okay. So does that answer the question? Now, hold on. I'm not hating on architects. Architects play a very, very important role, and architects and engineers, civil engineers, go hand in hand. Without one, you can't have the structures. You can't have our civilization. Civil engineers can just go and design buildings too, but if we did, most of them would just be straight up concrete boxes. So architects bring beauty and a purpose to our structures. So a lot of the structures that we'll see in this class, the architects played an important role, okay? So I'm not, and I think these comments are all pointed to other students who are starting to throw some shade at architects. Um, I'm certainly not doing that. I've worked with many architects in my career, and it was all great. And if you become a civil engineer, particularly a structural or a geotechnical engineer, you'll be working with a lot of architects too. Okay, so we're going to dive into one of my objectives today is to cover a couple, or at least one formal definition of what a civil engineer is. So this is definition number 1, and I describe it as civil engineers provide people with the basic necessities of survival, which are water, shelter, and transportation. So let's dive into this a little bit, okay? How do civil engineers provide us with water? So this is a satellite image. Does it look familiar to anybody? Does it look familiar to anybody? Okay, Jethro, what is that? Come on, I don't know. There. Oh, I just muted you. Unmute. Oh, there's like a delay on the unmute there.
Okay, can you hear me now?
I can hear you now because
Okay,
I kept remuting you, Jethro.
sorry.
No, I'm sorry.
I'm guessing that is Utah.
Yeah, can you guess which part of Utah?
I'm not super familiar, but is that the Salt Lake on the left?
Yeah, so on the upper top left in the corner is the Great Salt Lake, and that little blue lake down in the bottom left, that's Utah Lake.
Okay.
So BYU is right next to that, right? That's where we're located. So good job, Jethro, that's right. We're looking at a satellite image of essentially Provo, Utah, and all the mountains that are right to the east of us. Now, check this out. And again, I don't know if you guys can see my arrow. Can you guys see my arrow floating on the screen? Someone click yes if you can see it. Yeah, okay. So these, where my arrows is floating, do you see all these lakes of blue? All of those are reservoirs. And they're the reason why all the people who live in the Salt Lake Valley and in the Utah Valley can even live here. Because guess what? Utah is officially the second driest state in the country. The only state that's drier is Nevada. So we don't get a lot of rainfall or snowfall in Utah, but when it does come, we need to make the most use out of the water that we get. So civil engineers, beginning with the early pioneer engineers that came into the Salt Lake Valley in the 1840s, they strategically went to the catchments where all of the water runoff from the snow and the mountains would go and drain into the valley, and they started building dams to catch that water so that we could use it throughout the year. Civil engineers design systems like this to provide for the water needs of society. It's part of the reason why you can have such large populations in places like Southern California, parts of New Mexico, the entire state of Arizona, and Southern Utah, and of course, Nevada. Without these systems that can convey and also trap and store water, we wouldn't be able to have cities or societies in these locations other than just very small, almost like villages, just whatever could live off the immediate resources that are provided by the precipitation. So other things that we can notice, for instance, this is called a hydroelectric dam. So this used to be the largest dam in the world until the Three Gorges Dam was constructed in China. And these structures are massive. And you get a lot of functionality from dams like this. For instance, we get the water storage behind the dam so people can use the water, drink the water, and use it for irrigation and also recreation. But when the water spills through these inlets, there's turbines in there, and the water goes past the turbines and it generates electricity. So it becomes now a power plant that provides electrical power for nearby cities. But there's a lot that needs to go into the engineering of a structure like this. And we have to worry about particularly environmental aspects. For instance, what do we do with all the sediment that this river is carrying downstream, and then it hits this dam and gets deposited and just builds up and builds up and builds up? Dams have been known to change the temperature of the rivers. Dams have been known to change the demand of the water of the rivers. And so civil and environmental engineers need to consider all of these things to make sure that what we're building is sustainable and can last for generations and won't deplete all of our resources in 1 or 2 generations. I threw, what is this thing? You guys see this circle on here? I'm not exactly sure where that circle came from. Does anybody know where that circle came from on my screen? Jared or Stephanie, do you guys know where that is? Did I
do not.
Did I unwittingly draw that? All right, well, we'll put up with it for a minute. I'll figure it out later. But I wanted to show this little screen to you guys. This was something that I just pulled out of the news a couple days ago. And you guys have probably heard about this if you've been watching the news anytime recently. There have been some major rain events along the Yangtze River in China. That's where the Three Gorges Dam is. The Three Gorges Dam is massive. It's miles across, miles. And this dam goes across the entire river. And there was a lot of worry that the huge floods were going to destroy the dam, which would release tons of water and kill potentially millions and millions of people downstream of the dam. Engineers have safety systems in place that they released tons of flood water. So basically the dam wasn't retaining any water. Everything was just flowing right through the dam. And the dam was able to stay. It weathered the flood. And so it's really remarkable engineering. And it just shows what civil engineers today can accomplish. Now, those were really big dams. But what about small dams? So this is what's called a low head dam. This is just a little teeny cross section. And if any of you have gone fishing on the creeks or the streams here in Utah, you've probably seen dams like this. They do make some great fishing. I like to throw a fly up here above the dam because you got nice calm water. And the fish like to get down and hang out in front of this dam. These low head dams have been shown by research here at BYU to be very dangerous, actually. And many people have lost their lives because these low head dams get in here and they just churn and they churn. And anyone who gets caught, even the water's only as deep as maybe your thigh, but it doesn't matter because there's so much force that it just sucks you down and it holds you down. And so we've done a lot of research here at BYU about how to improve the safety of low head dams. Something else that's interesting, does anybody recognize these pipes? You probably haven't seen them, but I'm just curious if anybody knows what these pipes are. Any guesses? In the comments or raised hands? Okay, Trevor, let's see if I can unmute you successfully. Okay, Trevor.
Just like water transport?
Yep, they are water transport. Good job. You know where they are? Any guesses?
I'm not sure. I'm not from Utah, but maybe around here.
Yes, yes, you win. That's right. They are from around here. Great job, Trevor. These are pipes that run all the way down Provo Canyon, and they're way up on the bench. So if you drive up Provo Canyon, you can't see them. But they go all the way from Strawberry Reservoir, all the way down the canyon, and then around the point of the mountain into West Valley in the Salt Lake Valley. And it is a gravity-fed system. There's not a one single pump. So water from Strawberry flows straight down, and it's a pressure-fed system. So people in the Salt Lake Valley are obtaining their water from Strawberry Reservoir. Pretty incredible. Of course, we've talked a little bit about this, but it's so important today, especially with modern manufacturing and everything that we have going on with plastic production and paper production. We don't have a grasp yet on how to responsibly handle the waste products of these, especially in second and third world countries. So all of that garbage just ends up in the oceans or the rivers, and it makes people sick. And also the sewage that people have. We build these sewer pipes and these elaborate sewer systems, and we run them right to the, yeah, you guessed it, the drinking water source. And we dump it right in there. And so people, again, get sick. And so civil engineers and environmental engineers, we work to come up with systems and fail-safes to prevent this kind of stuff from happening and to keep our water crystal clear. Now, in a couple of weeks, we're going to introduce you guys to some faculty who will talk about some study abroad programs. But currently, the statistics show that about 30% of our department graduates go to places like the Dominican Republic, do a study abroad program, and they obtain some technical credit, and some even get some capstone credit doing a water design project in the Dominican Republic. We also have another one that goes to the Netherlands over in Europe, a water-based project. And so 30%, 1/3 of our graduates get involved in these types of projects. So it's pretty exciting. Okay, shelter. So shelter is, these are just some pictures of some amazing skyscrapers and some domes. A lot of these come out of China. A lot of them come out of the UAE, United Arab Emirates. You can see the artistic flair that are in these buildings. That comes from the architect. But the person who makes the buildings possible and actually figures out how to construct them, that's the engineer. So they work side by side. Why do you guys think there's these big holes in these buildings? What purpose do you think that serves? Anybody have a guess? Anybody? Okay, I see a couple hands here. Let's, oh, the hands disappeared. Oh, there's some. Okay, Grant.
That for wind, so that the wind can pass through it.
Perfect. That's great, Grant. That's absolutely right. So especially in these coastal cities where you have the potential for huge coastal storms and hurricanes to come and hit, if you have a solid wall, that's a lot of force pushing on that building. But if you have an opening, it reduces the lateral loads on the structures and it allows the wind to pass right through. Not just wind, we're finding that these are also very useful for things like tsunami waves. And so you're going to see more and more buildings like this in the coastal areas that have these holes in them. But not only that, they look cool and you get more window space. And so people are finding this type of construction really desirable. This is the airport in Beijing, and I just thought it was so fascinating. I don't know if any of you guys have ever been to the Beijing airport, but they have so much glass in that airport that they have something like 40 employees hired full-time who all they do every day is they clean the windows, and they just go all the way around, and by the time they get back around again, they're dirty again. So they're constantly just cleaning the windows in this huge airport. Let's talk a little bit about transportation. So here are some pictures of some beautiful bridges. This bridge, everybody should be familiar with, the Golden Gate Bridge. But you've probably never seen a picture like this. This is the construction of a new multi-span bridge over a big body of water. Notice how they built the support, we call it a bent, the bent of the bridge first, and then they started building out from both sides at an equal rate. And they did that to have equal balance on both sides of the bridge, or both sides of the bent. So it's like a teeter-totter that's in a perfect balance. And if I were to scroll the camera a little to the left, you'd see another one of those being built. And eventually what happens is those construction zones, they meet up and then they link the bridge. And this is how they can construct some of these amazing bridges, really, really long bridges over these spans of water. And they don't require a ton of cranes, which is really remarkable. You got these beautiful arch bridges. So again, we have architects involved. This currently is the longest bridge in the world. It's down in China. I can't remember the name of it, but it is incredibly long. And it's just multi-span bridges that goes over several islands. I'll have to look up the statistics on it, but it is, if I recall, it is, I believe, more than 100 miles long, which is, when you think about it, just blows your mind. But transportation is more than just building bridges. We also want to work on public transportation. So how do we transport a lot of people in an urban place where we don't have room for everybody to have cars? And we want to get a lot of people from one place to another. And so we develop systems like high-speed rail or monorails. And these systems are capable of transporting people in all of these urban centers in a way that's very, very rapid. But it doesn't just transport people within the urban center, it also transports people from place to place. If you've ever been to Europe, it's remarkable because you can go from any city to any other city in Europe on trains for an incredibly low price. And they're fast. Now, this train here in China is a bullet train, which means that it's going about 430 kilometers per hour. That's more than 200 miles per hour. This is, we used to have a study abroad program that went to China before things got a little scary between our two countries. And this was a former BYU student who was just amazed that he's standing up on a train traveling more than 200 miles per hour. Other things we worry about with transportation are transport of products. This is a port in China. And if you think about how many products that we have in the US or throughout the world that come from places like China, chances are, if you're wearing a t-shirt or a blouse or jeans, they were manufactured in China. And they came from there to here in a cargo box or cargo container similar to this. It's estimated that more than 1/3 of all retail products sold in the United States goes through the Port of Long Beach in Los Angeles, comes in, gets processed, and gets distributed out to various stores throughout the United States. It's incredible, and civil engineers are heavily involved in things like transport of retail and products in rail and in airlines. So all of that is important as transportation goes. So definition number 2, we're going to get to this next week. This has been a good learning experience for me. So what I'm going to ask everybody to do who's still here on the, okay, I just saw a line appear on the screen. So somebody's drawing on the screen. I'm gonna have to figure that out. It wasn't me, I didn't do it. Everybody who's here in class, if you'll clear your participant board and then go to raise your hand to show that you are still here. We're going to take a roll right now, and Stephanie and Jared, if you guys want to go through and just take a very quick roll. And we're going to hang on there. So while you guys are taking roll, if anybody else has any questions that they want to ask, go ahead and type it into the chat box. So let's go ahead and open that up for questions. Or let's just do this. If you have a question and you want to ask it, this will be more efficient. Change your symbol from hand up to yes. And I'll call on you and you can ask your question. Let's see if we can. Okay, we got a couple questions here. Griffin, I'm going to unmute you.
Hey, so my question was, if you're a civil engineer, like it seems like you have to take a lot of things into consideration. How do you like best manage that? Like all the factors, like because of like the bridge you showed us in the beginning with all the dirt, the grass, like the wind, like earthquakes, like it just seems like a lot, you know?
Yes, so that's a good question. As you'll learn as we go through this class, civil engineers, they work in teams. And no engineer is expected to know everything and to be able to take everything into account, because our infrastructure systems have become way too complex for one person to be master of everything. And so probably more than any of the other engineering disciplines, we work in teams a ton in civil engineering. And it's one of the things that I really enjoy about it. So if you go into civil engineering, you're going to specialize in one or maybe two things, and then you're going to work with other professionals to solve those problems. Good question. We'll talk more about that through this semester. Okay, maybe we're out of time. It's 2:50, so I see that there's some other questions. Feel free to shoot me a message or send me an email. I'd be happy to respond to those, or we'll get to them next week. I see a lot of drama and debate over the circle, the mystical circle. I don't know what that is, but I'm going to ask, out of courtesy, that you not draw on the middle of the lecture slides during Zoom next week. That would be great. Okay, thank you everybody, and I'll catch you next week at 2 o'clock. Thank you for joining.